This video is on triangle theorems. We're going to be talking about the triangle angle sum theorem. We're going to talk about the triangle exterior angle theorem. And we'll be talking about the perpendicular bisector theorem in this video. The triangle angle sum theorem states that the sum of the measures of the angles of a triangle is 180 degrees. It just states that all angles in a triangle will add up to 180 degrees. So to apply this, we're going to use this theorem to figure out the values for x, y, and z. So we have multiple triangles in here. We actually have triangle ABD, triangle CBD, but we also have triangle ABC. So you can use any part of that to help you. So if you notice, x is actually in angle ADB. You cannot say that x is at angle D because there's two letters there. So A to D to B, that's where x is. That's actually part of triangle ABD, and we have two angles in ABD. We have the 43 here and the 59 here. So that means that these three angles will add up to 180 degrees. So to find x, I'm going to take the 43 degrees, going to add it to the 59 degrees, and I'm going to add it to the x. And these should add up to 180 degrees. So to solve for this, I'm going to add the 43 and 59 and subtract it from 180. So we end up getting x is equal to 78. Now, we could either find y next or z next. Again, it all depends on what you want to look for. I could find z next by stating I know that z is angle C, which is part of triangle CBD, but notice that I have two variables here, so I can't determine what both of them are at the same time. But C is also part of triangle ABC. So I have all of angle A is 59 degrees. All of angle B would actually be 43 and 49 together, and then I would just be missing C. So I could find Z that way. Or you could find angle Y first, because angle Y, the degree of Y and the degree of X, actually form a linear pair. Therefore, these two angles are supplementary to each other. So I can actually say, since I know x, I know that x plus y is equal to 180 because it's a linear pair. That is actually much easier to do. So to solve for y, I can do x plus y equals 180. And I know x, we already know x is 78. So it's 78 plus y is equal to 180. Therefore, y is equal to 102 degrees. Which now, I don't have to do all that work to find z. I now have y, and I have triangle DBC right here, and I know y, I know the 49, so I can find z. So now z will just be your 49 degrees plus the 102 degrees, which was our y, plus z is equal to 180. So now z, if I add 49, 102, and subtract it from 180, we get z is equal to 29. So again, you could do it a different way. It just all depends on how you see it and how you want to manipulate it. But if you can see that these are attached to each other, you can go from one triangle into the next triangle. That is one thing you should always be able to do. Figure out how to solve for the entire small triangle and go into the bigger triangle, or vice versa, but you should always, if you see something connected, try to go from one triangle into the next triangle. That way you can finish the other triangle. The next theorem we're talking about is the triangle exterior angle theorem. It states that the measure of each exterior angle of a triangle equals the sum of its two remote interior angles. So let's define those. The remote interior angles and exterior angle. The remote interior angles are the two non-adjacent interior angles corresponding to each exterior angle of a triangle. So exterior angle is an angle formed by the side of a triangle and an extension of an adjacent side. So if we look up here, this side right here is not extending. This side is not extending. This side is extending. So we actually have an extension of a side and another side. So we have an exterior angle right here. So I will actually highlight the exterior angle in blue. This is our exterior angle. So the remote interior angles go back to the non-adjacent interior angles corresponding to each exterior angle. So these, what it's talking about with non-adjacent, means that angle 2 and angle 3 are non-adjacent to the exterior angle. So these are not touching that exterior angle. So angle 2 and angle 3 are non-adjacent to angle 1. These are your remote interior angles. What that states is that these two angles, angle 2 and 3, add up to be angle 1. Now, it's really important to know this theorem, especially if there are variables in your problem. However, if these are all just numbers, you can find this value by adding these two up and subtracting it from 180, because all three of these angles will add up to 180. So we can find this angle. Then this angle and the 1 are a linear pair, so they're supplementary. So you can subtract this angle from 180 to get to the outside. You can do that with numbers, but if you have variables, it's much more difficult. So this example that we're going to do is to solve for x and the missing angle measurements. So since there are variables in here, this is why you want to know that the exterior angle is equal to the sum of the remote interior angles. So on this problem, our exterior angle, I'm going to highlight back in blue, this side is being extended. So I have this exterior angle. It's equal to the sum of the remote interior angles, the non-adjacent angles. These are non-adjacent to that blue highlighter. That means that we can add those up. So I have 4x plus 20 plus the 54 degrees is equal to the exterior angle, which is 9x plus 19. Again, because these are not just numbers, we want to make sure we actually know the exterior angle theorem. So now we have 4x plus 20 plus 54 is equal to 9x plus 19. So we have 4x plus 74 is equal to 9x plus 19. Now to subtract the 4x and then subtract the 19, 74 minus 19 is 55, is equal to 9x minus 4x is 5x. Then to solve for x is equal to 11. So we found the variable, solve for x. Now we need to find the missing angle measurements. So the measure of angle GBC is, you do 9 times 11 is 99, plus 19 is 118 degrees. So the measure of angle GBC is equal to 118 degrees. We already have the measure of angle C. And I can say C because there's only one angle at C. I can also say angle D because there's only one angle at D. I had to use 3 letters at GBC because there are 2 angles at letter B, at that vertex of B. So I have to make sure I definitely know which one I'm talking about. So then to plug x into our angle D, 4 times 11 is 44, plus 20 is 64. So then the measure of angle D is equal to 64. And those are all 3 of our answers. The perpendicular bisector theorem states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if we have a point is on the perpendicular bisector of a segment, so this is considered your perpendicular bisector because this line, segment, or line is perpendicular to segment AB because of the right angle, and it is bisecting segment AB because you have two congruent segments and M is in the middle of that. So that is the perpendicular bisector. Now point P is on that perpendicular bisector. Therefore, this states that point P is equidistant to A and to B. Equidistant means it's equal distance. So from P to A is the exact same from P to B. So we really have an isosceles triangle. We could connect PA and PB and put congruent marks on them because it forms an isosceles triangle. So the perpendicular bisector theorem is used for isosceles triangles. So for this example, we're going to solve for the side measurements. For this picture, we have tick marks down here, which states that NO is congruent to PO, segment PO. That means that it's being bisected, and it has a right angle. Therefore, segment MO is the perpendicular bisector of segment MP. So I'm going to write that statement. Segment MO or OM, so segment OM is the perpendicular bisector of NP. So since it's a perpendicular bisector, that we can then state that segment NM is congruent to segment PM. So segment NM is congruent to segment PM because it's the perpendicular bisector. So since they are congruent, we can set them equal to each other. So we can actually put the tick marks on here. We'll use 2 tick marks because we don't know if they're congruent to NO and PO, but we do know they're congruent to each other. So we can say 6x minus 1 is equal to 3x plus 8. Subtract the 3x, we have 3x. Add the 1, we get 9. So x is equal to 3. We divide by 3. Now to find the side measurements, we plug them back in. So in M, we plug in 6 times 3 is 18, minus 1 is 17. So the length of NM is equal to 17 units. Then it should be the same for PM. So 3 times 3 is 9, plus 8 is 17. So the length of PM is also equal to 17 units. So that means that we were correct in our math.